and welcome to the Screencast, where we will look at using the arc length formula. In a previous video, we saw that if a central angle measuring theta radians, and remember that angle must be measured in radians, intercepts an arc of length s and a circle of radius r, then s, the arc length, equals r, the radius, times the angle theta in radians. Let's look at how this would actually be used in non-unit circles. So our first example says, determine the arc length intercepted by a central angle of 5 pi over 3 in a circle of radius 7. So we know a couple things here. We know that s, the arc length, equals the radius times the angle theta measured in radians. It says determine the arc length, so we're trying to find s. We know the central angle is 5 pi over 3, and we know the radius is 7. So we can get a visual of this to help us think about what we're finding. If the central angle is 5 pi over 3, then that's going to be somewhere about here from what we know about the unit circle in central angles. And then we also know that the radius equals 7. And we are trying to find the arc length. So we're trying to find the length along the circle that would intercept that central angle. So we'll use our formula. S equals r times theta. The radius is 7. The angle was given in radians, 5 pi over 3. So we see that the arc length would be 35 pi over 3. So again, that means that this distance around the circle until we get to 5 pi over 3 as the central angle, that distance is 35 pi over 3. All right, let's look at our next example. Determine the central angle. So this time we're trying to find theta that intercepts an arc of length pi over 6. So we know s, and the radius is 3. So this time let's use our formula and then we'll sketch what we found. So we know s equals r times theta. We're trying to find theta. So theta would equal we know the arc length is pi over 6. We know the radius is 3. We're trying to find theta. I would multiply by the reciprocal of 3. So we find out that our central angle is pi over 18. So if we're trying to sketch what we just found, it's going to be a little challenging, but our central angle would be this small angle here, pi over 18 radians. The radius was 3, and the arc length, so this length here along the edge of the circle, is pi over 6. All right, we'll look at two more examples. Determine the radius of a circle, so we're trying to find r, in which an angle of 5 pi over 4, so there's our central angle, intercepts an arc of length pi over 8. So we know s. All right, so thinking about the unit circle, we do know that 5 pi over 4 is in the third quadrant. So here's our central angle, 5 pi over 4. We know the arc length, so the length along the circle until we get to that central angle, is pi over 8, which is a lot smaller than the central angle, 5 pi over 4. So one thing that does tell us is that the radius is going to be quite small. But we can use our formula. S arc length equals radius times theta to find the radius. So we'll substitute what we know. The arc length is pi over 8. We're trying to find the radius. And we know our central angle is 5 pi over 4. So we'll multiply by the reciprocal, 4 over 5 pi. And when we simplify that, we find out that the radius is 1/10. So in fact, that reasoning that the radius would have to be really small because this arc length is a lot smaller than the central angle proved to be true. All right, last example. Determine the exact coordinates of the point on a circle of radius 2 that lies 5 pi over 3 units counterclockwise along the circle from 2, 0. So this one's a little challenging because you see this 5 pi over 3, you might be thinking, oh, that's an angle on the unit circle. Yeah, it is, but we're not told that this is an angle. We're told that the point lies 5 pi over 3 units counterclockwise along the circle from 2, 0. So all of that info together is actually telling us that the arc length is 5 pi over 3. So we know S. And we also know the radius is 2. So we're trying to find the exact coordinates, but to do that, we're going to first need to find the central angle. So we're going to take arc length equals radius times theta, the central angle. 5 pi over 3 is the arc length. The radius was 2. We'll multiply by the reciprocal of 2, which is 1/2. So we see that our central angle is 5 pi over 6. So just thinking about what we do know on the unit circle, a central angle of 5 pi over 6 would be about here. The radius was 2. So remember, this point on the circle is going to be 2 times bigger. So the x-coordinate will be 2 times bigger, and the y-coordinate will be 2 times bigger than whatever the coordinate is on the unit circle. So on the unit circle, that point at 5 pi over 6 would be at -3/2, comma 1/2. But since this circle is twice as big in radius, for this circle, the coordinate will be -√3 because we multiply -√3 over 2 times 2. And then 1 because we take 1/2 times 2 as well. All right, I hope that helped.